Welcome to the first Python programming class. Introduction. In this lesson, we will learn the basics of programming, data types, operators, mathematical and logical, and variables. Data types. Data represents information we store in our memory, such as a birth date, a phone number, a temperature, a quantity of something, or an age. Each piece of data or information belongs to a different category, such as a text, called a string, represented by quotation marks, a number, integer or float, a boolean, true or false, or a list of various data types. Mathematical operators. Mathematical operators are used to perform calculations and operations with numbers. Basic mathematical operators are addition, subtraction, multiplication, and division. We also have commonly used advanced mathematical operators such as exponentiation and modulo, remainder of a division. Logical operators. Logical operators are used to make comparisons and decisions based on conditions. The most common operators are and, or, and not. Variables. Variables are used to store information in the computer's memory. We can assign names to variables to refer to them in the code. In the next lesson, we will explore how to use mathematical operations and conditional structures. Welcome to the second Python programming class, Mathematical Operations and Conditional Structures. In this class, we will cover three main topics: mathematical functions, real and complex numbers, and rounding. Let's start with mathematical functions. Mathematical functions are used to perform advanced calculations such as sine, cosine, and tangent. Let's see practical examples using the math library. For example, we can calculate the sine of an angle. To do this, we use the sin function. Remember to convert the angle to radians using math radians. Similarly, we can calculate the cosine of an angle using math cos. To calculate the tangent, we use mathtan. Note that the tangent of 90 degrees can cause errors due to its mathematical nature. The math library also offers other useful functions, such as square root. Here's an example. Now let's talk about real and complex numbers. Real numbers include all numbers that can be represented on the number line. Here's an example of usage. Complex numbers have a real and an imaginary part. In Python, they are represented in the format a dj. We can access the real and imaginary parts of a complex number directly, as well as perform operations with them. Now let's move on to the topic of rounding. Rounding numbers is useful for formatting values. We can use functions such as round, ceil, and floor. Now that we've covered mathematical operations, let's learn how to use conditional structures. Here's a simple example of using if-elses. For multiple conditions, we use a leaf. Here's an example. In the next class, we will explore how to use loops and lists in Python. Welcome to the third Python programming class, Loops and Lists. In this class, we will cover three main topics: loops, list operations, and list comprehensions. Let's start with loops. Loops are used to execute a block of code repeatedly. The two main types of loops in Python are for loops and while loops. A loop iterates over a sequence, like a list or a string. Here is an example using a list of fruits. In this example, the loop iterates through each fruit in the list and prints a message for each one. Next, we have while loops, which continue to execute as long as the condition is true. Here's an example of count. Now let's talk about list operations. Lists are a collection of items that can be changed and ordered. They allow duplicate members. We can perform various operations on lists, such as adding, removing, or accessing elements. Here's how to remove an item. We can use the remove method. Here's an example. You can also access elements in a list using their index. Remember that Python uses zero-based indexing. Lists also support slicing, allowing you to access a portion of the list. For example, you can get the first two elements. Another useful method is sort, which will sort the list in ascending order. Here's an example with numbers. Now, let's move on to list comprehensions. List comprehensions provide a concise way to create lists. They consist of brackets containing an expression, followed by a for clause. Here is an example that creates a list of squares. List comprehensions can also include conditionals. For example, here's how you can create a list of even squares. In summary, we've covered loops, various list operations, and how to create lists using list comprehensions. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. In the next class, we will dive into functions and modules in Python. Welcome to the fourth Python programming class. Functions and modules. In this class, we will cover four main topics: defining functions, function parameters. Let's start with defining functions. Functions are a block of code designed to perform a specific task. You define a function. Here's an example of a simple function that prints a greeting. You can also define functions that return values. Here's an example of a function that adds two numbers. Now let's talk about function parameters. Parameters allow us to pass information to functions. We can define default values for parameters as well. Here's an example of a function with a default value for a parameter. We can also use args and kwargs to handle variable numbers of arguments in a function. Now let's move on to importing modules. Modules are Python files containing reusable code. You can import a module to use its function. For example, let's import the math module. You can also import specific functions from a module using the from keyword. Additionally, you can create your own module by writing functions in a separate Python file. Now let's discuss higher order functions, which are functions that can take other functions as arguments or return them. An example of a higher order function is map, which applies a function to all items in an iterable. In summary, we've covered how to define functions, use parameters, import modules, and understand higher order functions in Python. Before we conclude, let's recap the key takeaways from today's class. In the next class, we will explore file handling and error management in Python. Welcome to the 5th Python programming class, File Handling and Error Management. In this class, we will cover 5 main topics: reading files, writing files, handling exceptions, using the with statement, and file operations. Let's start with reading files. To read a file in Python, you can use the open function. Here is an example of reading the contents of a text file. Don't forget to close the file after you're done. Here's how you can do that. You can also read a file line by line using a loop. Let's expand this by reading the file and counting the number of lines. Now let's talk about writing files. To write to a file, you also use the open function with the W mode. Here's how you can write a string to a file. This will create a file named output.txt and write hello world into IT. If the file already exists, using W mode will overwrite the existing file. If you want to append the file, use a mode instead. Let's add a feature that writes multiple lines to a file. Next, let's move on to handling exceptions. Exceptions are errors that occur during program execution. You can handle them using try except blocks. Here's an example that demonstrates exception handling when trying to divide by 0. You can catch multiple exceptions as well. Here's how you would do that. Now let's explore the with statement, which simplifies exception handling by encapsulating common preparation and cleanup tasks. The with statement is commonly used for opening files because it automatically takes care of closing the file for you, even if an error occurs. In addition to file handling, you can also use with for managing resources such as network connections or threading locks. Next, let's discuss some common file operations. You can check if a file exists using the OS module. Additionally, you can read and write JSON files easily with the JSON module. In summary, we've covered file handling, including reading and writing files, exception handling, the use of the with statement, and basic file operations in Python. In the next class, we will explore object-oriented programming in Python. Welcome to the 6th Python programming class, Object-Oriented Programming. In this class, we will cover 5 main topics: classes and objects, attributes and methods, inheritance, polymorphism, and encapsulation. Let's start with classes and objects. A class is a blueprint for creating objects. You define a class using the class keyword. Now let's talk about attributes and methods. Attributes are variables that belong to a class, and methods are... Here's an example where we add a method to the car class. Next, let's move on to inheritance. Inheritance allows a class to inherit attributes and methods from another class. This promotes code reusability. Here's an example of inheritance where we create a class electric-car that inherits from car. Now we can display both the car info and battery information. Finally, let's explore polymorphism. Polymorphism allows methods to do different things based on the object calling them. For example, we can define a method start in both car and electric car classes and override it in electric cars. Now, we can see polymorphism in action. Next, let's dive into encapsulation. Encapsulation is the bundling of data with the methods that operate on that data. It restricts direct access to some component. In Python, we can indicate that an attribute is private by prefixing the name with an underscore. Initiation can also be achieved through properties. Let's add some getter methods. In summary, we've covered the basics of object-oriented programming, including classes and objects, attributes and methods, inheritance, polymorphism, and encapsulation. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. In the next class, we will delve into Python libraries and frameworks. Welcome to the 7th Python programming class, Python libraries and frameworks. In this class, we will cover 5 main topics: introduction to libraries, popular Python libraries, frameworks overview, installing libraries, and using virtual environments. Let's start with introduction to libraries. A library in Python is a collection of modules or packages that provide reusable code to accomplish specific tasks. Libraries help to reduce redundancy and promote efficient coding practices by allowing developers to use pre-written code for common tasks. Let's look at how libraries contribute to code maintainability by enabling easier collaboration. Next, let's discuss popular Python libraries. Some of the most widely used libraries in Python include NumPy for numerical computations, Pandas for data analysis, Matplotlib for data visualization. Here's how you would import these libraries after installing them. Now, let's explore more libraries. Now, let's move on to frameworks overview. Frameworks provide a structure for building applications. They can be categorized into web frameworks, data analysis frameworks, and more. Popular web frameworks include Flask and Django, whereas for data analysis, we have TensorFlow and PyTorch. In the context of web development, we will also briefly discuss RESTful APIs and how frameworks facilitate building them. You can install Python libraries using pip, which is the package installer for Python. Remember to keep your libraries updated by using the command. Let's also touch on creating requirements. Finally, let's discuss using virtual environments. Created virtual environments help manage dependencies for different projects. To activate the virtual environment, you would run Be sure to deactivate your virtual environment using deactivate when you're done working in it. In summary, we've covered the basics of Python libraries and frameworks, including popular libraries. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. In the next class, we will explore data science and machine learning concepts in Python. Welcome to the 8th Python programming class, Data Science and Machine Learning. In this class, we will cover 6 main topics: Introduction to Data Science, Key Libraries for Data Science, Introduction to Machine Learning, Training and testing models, evaluating models, and practical hands-on exercise. Let's start with Introduction to Data Science. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights. It combines expertise from statistics, computer science, and domain knowledge. Let's explore some real-world applications of data science. Applications include finance for let's discuss key libraries for data science. Essential libraries in data science include NumPy for numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for data visualization. and SciP for scientific computing. Now, additionally, we have scikit-learn for machine learning, NLTK for natural language processing, and TensorFlow Keras for deep learning, which we will explore later. Machine learning is a subset of artificial intelligence that enables systems to learn from data and improve their performance over time without being explicitly programmed. It involves training models based on labeled datasets to make predictions. Let's categorize machine learning into 3 types: supervised, unsupervised. Next, let's learn about training and testing models. To build a machine learning model, you typically split your dataset into a training set and a testing set. The training set is used to train the model, while the testing set is used to evaluate its performance. Here's an example. Additionally, we can use cross-validation to evaluate the model's robustness. Let's discuss evaluating models. Common evaluation metrics include accuracy, precision, recall, F1 score. To evaluate classification models, you can create a confusion matrix using the following code. In summary, we've covered the introduction to data science and machine learning. To solidify your understanding, let's engage in a practical hands-on exercise where we'll build a simple machine learning model together. In the next class, we will dive into data visualization techniques in Python. Welcome to the 9th Python programming class, Data Visualization Techniques in Python. In this class, we will cover 5 main topics: Introduction to data visualization, importance of data visualization, popular visualization libraries, creating visualizations, and advanced visualization techniques. Let's start with Introduction to Data Visualization. Data visualization is the graphical representation of information and data, which helps to communicate insights clearly and effectively. Visualizations can take many forms, including charts, graphs, and maps, and it enhances comprehension by simplifying complex data and making it accessible. Some of the most popular libraries for data visualization in Python include matplotlib, Seaborn, and Plotly. Matplotlib is great for basic plots, while Seaborn offers a higher level interface for drawing attractive statistical graphics. Plotly enables interactive plots, which can be beneficial for dashboards and web applications. Here's a simple example of how to create a line plot using Matplotlib. Additionally, you can create more complex visualizations using Seaborn for statistical data, like this. Now let's create a bar plot using Plotly, which demonstrates interactivity. Lastly, let's discuss advanced visualization techniques. Advanced techniques may include 3D plotting, geographical mapping with Folium, and interactive dashboards using Plotly Dash. These techniques allow for deeper analysis and more compelling presentations of data insights. Furthermore, consider using libraries like Bokeh for interactive visual. Let's also touch on the aspect of choosing the right type of visualization for your data. In summary, we've covered the introduction to data visualization, its importance, popular libraries, how to create visualizations, and advanced techniques. Here are the key takeaways. Understand the variety of visualization methods, know the libraries available, and practice creating your own visualizations. In the next class, we will explore real-world data manipulation using pandas. Welcome to the 10th Python programming class, Real-World Data Manipulation Using Pandas. In this class, we will cover 6 main topics: introduction to pandas, data structures in pandas, data cleaning and preparation, data analysis techniques, data visualization fundamentals, and a practical data manipulation exercise. Let's start with introduction to pandas. Pandas is a powerful Python library for data manipulation and analysis, providing flexible data structures that make data work easy and efficient. It is particularly useful for handling structured data, such as tables. The 2 primary data structures in pandas are series and data frame. A series is essentially a one-dimensional array, while a data frame is a 2-dimensional, size-mutable, and potentially heterogeneous tabular data structure. Next, let's explore data cleaning and preparation. Data cleaning involves handling missing values, removing duplicates, and converting data types. Here's how you can handle missing values in a data frame. You can also drop duplicates using the following command. Now let's discuss data analysis techniques. Pandas provides powerful functionalities for data analysis, including aggregation, grouping, and merging data. For example, to calculate the average age in the data frame we created earlier, you can use Let's also explore grouping data. For example, if we had a column for gender, we could group by gender to analyze age distribution. Next, we will cover data visualization fundamentals. Data visualization is crucial for interpreting data analysis results. We will use the Seaborn library to create visualizations. Finally, let's engage in a practical data manipulation exercise. In this exercise, we will work with a CSV file, perform data cleaning and analysis, and visualize the results. Let's start by loading a CSV file into a data frame. In summary, we've covered the introduction to pandas, data structures, cleaning and preparation techniques, data analysis, visualization fundamentals, and a practical exercise. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand the importance of pandas. Know how to create and manipulate data frames, clean and analyze data, and visualize results. In the next class, we will introduce you to advanced statistical analysis techniques. Welcome to the 11th Python programming class, Advanced Statistical Analysis Techniques in Python. In this class, we will cover 6 main topics. Introduction to statistical analysis, descriptive statistics, inferential statistics, hypothesis testing. Let's start with the introduction to statistical analysis. Statistical analysis involves collecting and analyzing data to identify trends and patterns, drawing conclusions, and making decisions based on data. It is a fundamental aspect of data science, enabling professionals to make informed decisions. Next, let's discuss descriptive statistics. Common descriptive statistics include measures of central tendency like mean, median, and mode, as well as measures of variability like range, variance, and standard deviation. Now let's explore inferential statistics. Inferential statistics allow us to make inferences and predictions about a population based on a sample of data drawn from that population. It includes techniques such as confidence intervals and hypothesis tests, which help us draw conclusions about a population from sample data. Let's move on to hypothesis testing. Hypothesis testing is a statistical method that uses sample data to evaluate a hypothesis about a population parameter. For example, you might want to test if the average height of a group of people is significantly different from a known average height. Lastly, let's discuss regression analysis. Regression analysis helps us understand relationships between variables, allowing us to predict outcomes based on input values. The most common type is linear regression, which fits a straight line to the data points. Here's an example using the stats models library. In addition to linear regression, we may also explore multiple regression analysis, which uses multiple variables to predict an outcome. Now, let's delve into some advanced topics in statistical techniques. Logistic regression is used when the dependent variable is binary. It predicts the probability of an event occurring. ANOVA, analysis of variance, is used to compare means across multiple groups to see if at least one group differs significantly. In summary, we've covered the introduction to advanced statistical analysis, descriptive statistics, inferential statistics, hypothesis testing, regression analysis, and advanced techniques, such as logistic regression and ANOVA. Key takeaways. Understand various statistical methods, know how to perform descriptive and inferential statistics, conduct hypothesis testing, regression analysis, and delve into advanced. In the next class, we will delve into time series analysis and forecasting techniques. Welcome to the 12th Python programming class, time series analysis and forecasting techniques in Python. In this class, we will cover 8 main topics. Introduction to time series analysis, time series data structures, time series visualization, seasonal decomposition, forecasting methods, model evaluation techniques, practical implementation, and future trends in time series analysis. Let's start with the introduction to time series analysis. Time series analysis involves understanding and modeling data that is collected over time. It helps in identifying trends, seasonal patterns, and potential cyclic behavior in datasets such as stock prices, weather data, or sales figures. Next, we will learn about time series data structures. In Python, the Pandas library provides a powerful way to work with time series data. The key data structures include datemindex, series, and dataframe. Here's an example of creating a time series using Pandas. Let's move on to time series visualization. Visualizing time series data is crucial for. Here's a simple example of plotting a time series. Now let's discuss seasonal decomposition. Seasonal decomposition helps us separate a time series into its seasonal, trend, and residual components. Next up, let's discuss forecasting methods. There are various forecasting methods, such as moving average, ARIMA, and exponential smoothing. Let's implement a simple example using ARIMA. Finally, let's cover model evaluation techniques. Here, model evaluation is critical. For determining the effectiveness of forecasting models, common evaluation metrics include mean, absolute error, MAE, root mean squared error, RMSE, and mean absolute percentage error. It's also essential to visualize evaluation metrics versus actual values. In summary, we've covered the introduction to time series analysis, data structures, visualization techniques, seasonal decomposition, forecasting methods, practical implementations, and model evaluation techniques. Before we conclude, Let's recap the key takeaways from today's class and open the floor for questions. Key takeaways: understand time series analysis fundamentals, learn to create and visualize time series data, explore different forecasting methods, evaluate models using metrics like May, RMSE, and visualize results. In the next class, we will explore advanced data visualization techniques with libraries like Seaborn and Plotly. I encourage you to work on a mini project where you apply these techniques to your own time series dataset. You can start by collecting data from APIS or using datasets from Kaggle. Welcome back to the 13th Python programming class, Advanced Data Visualization Techniques with Seaborn and Plotly. In this class, we will cover 11 main topics: Introduction to Data Visualization, Seaborn Basics, Seaborn Advanced Techniques, Plotly Basics, Plotly Advanced Visualization, Integration with Dash, Best Practices in Data Visualization, Data Storytelling, A/B Testing Visuals, Interactive Dashboards, and Resources for further learning. Let's start with the introduction to data visualization. Next, let's dive into Seaborn-based data visualization. Is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. Now let's move on to Seaborn advanced techniques. Seaborn offers a range of visualizations, including pair plots. Let's take a look at how to create a violin plot. Let's also create a pair plot to visualize relationships between all features. Next, we will discuss Plotly basics. Plotly is a library that allows you to create interactive plots. It is particularly useful for web applications. Here's a basic example of creating an interactive line plot with Plotly. Now, let's explore Plotly advanced visualization techniques. Plotly allows more complex visual. Here's an example of creating a 3D scatter plot. Next, we will discuss integration with Dash. Dash is a framework built on top of Flask, Plotly.js, and React.js. Let's outline a simple Dash application. Next, we'll touch on data storytelling. Data storytelling is about combining data visualization with narrative. It helps to engage the audience and convey the data's message effectively. Now, let's explore A/B testing visuals. A/B testing is crucial for comparing two versions of a web page or product to see which performs better. Here's how to visualize A/B test results. Now let's discuss interactive dashboards. Dashboards allow users to interact with data more dynamically. Here's how to create a basic dashboard featuring controls. Finally, let's discuss resources for further learning. Here are some resources to continue enhancing your data visualization skills. Official documentation for Seaborn, Plotly, and Dash, online courses and community forums. In summary, we've covered the introduction to data visualization, explored the basics and advanced techniques of Seaborn and Plotly, discussed integration with Dash. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand the importance of data visualization. Learn how to use Seaborn for basic and advanced visualizations. Explore Plotly for interactive plots. Recognize best practices in visualizations. Appreciate data storytelling. Leverage A/B testing visuals and interactive dashboards. In the next class, we will explore machine learning techniques to further enhance our data analysis skills. Welcome to the 14th Python programming class. Introduction to Machine Learning Techniques in Python. In this class, we will cover 8 main topics. Introduction to machine learning. Supervised learning, data preprocessing. Feature engineering, model selection, model evaluation, machine learning. Let's start with the introduction to machine learning. Machine learning is a branch of artificial intelligence that allows systems to learn and improve from experience without being explicitly programmed. It is applied in various fields, such as finance, healthcare, and marketing. Now let's break down the types of machine learning. There are 3 main categories: supervised learning, unsupervised learning, and reinforcement learning. Now, Let's explore data preprocessing. Supervised learning involves training a model on labeled data, while unsupervised learning deals with unlabeled data to discover hidden patterns or groupings. Common algorithms for supervised learning include linear regression and decision trees. And for unsupervised learning, clustering algorithms like k-means and hierarchical clustering. Let's move on to feature engineering. Feature engineering is the process of selecting, modifying, or creating new features to improve model performance. Feature selection is also vital, helping to identify the most relevant features to include in the model. Next, we will discuss model selection. Choosing the right model is critical for successfully solving a machine learning problem. You must consider the type of data and the specific problem. When selecting algorithms, such as regression, classification, or it is useful to understand and let's cover model evaluation. Model evaluation is essential to assess how well your machine learning model performs. Common evaluation metrics include accuracy, precision, recall, and F1 score for classification tasks, and mean squared error for regression tasks. Also, cross-validation is a technique that helps ensure your model's robustness. Let's proceed to practical implementation. In this section, we will implement a simple machine learning model using scikit-learn for classification. Here's how to build and evaluate a classification model. In addition to classification, we will briefly touch on regression tasks and how to implement them using linear regression. Finally, let's discuss future trends in machine learning. Machine learning is an ever-evolving field with ongoing trends such as federated learning, automated machine learning. The integration of ethical considerations and responsible AI development is also increasingly important. In summary, we've covered the introduction to machine learning, the distinctions between supervised and unsupervised learning, data preprocessing. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand the fundamentals of machine learning. Learn about supervised versus unsupervised learning. Preprocess data effectively. Engineer meaningful features. Select appropriate models. Evaluate model performance. And stay informed on future trends in the field. In the next class, we will delve deeper into supervised learning methods and their applications. Welcome to the 15th Python programming class, Supervised Learning Techniques in Python. In this class, we will cover the following topics: Introduction to Supervised Learning, Types of Supervised Learning, Key algorithms in supervised learning, data splitting, overfitting, and underfitting. Hyperparameter tuning, model validation, evaluation metrics, common pitfalls, and real-world applications of supervised learning. Let's start with the introduction to supervised learning. Supervised learning is a type of machine learning where the model is trained on labeled data. The model learns to predict the output from the input data based on the examples provided during training. This learning process. Next, let's discuss the types of supervised learning. There are mainly two types of supervised learning tasks: regression and classification. Regression is used when the output is continuous, while classification is used when the output is categorical. Now let's explore key algorithms in supervised learning. Some popular algorithms include linear regression, logistic regression, decision trees, random forest, support vector machines, and neural networks. We will also touch upon ensemble methods and deep learning approaches. In supervised learning, it is essential to split the data into training and test sets to validate the model's performance. A common practice is to use a 70-30 or 80-20 split. We can also consider techniques such as k-fold cross-validation for more robust evaluation. Next, let's discuss overfitting and underfitting. Now, overfitting occurs for hyperparameter tuning. Involves finding the optimal settings for the model's parameters. Techniques such as grid search and random search can be used to tune hyperparameters effectively. Additionally, Bayesian optimization is an advanced method worth considering. Let's move on to model validation. Model validation is crucial to evaluate how well your model generalizes to unseen data. Let's discuss evaluation metrics. Now, evaluating the performance of your model is vital. For regression, metrics like mean absolute error, may, and mean squared error are unused for classification. When implementing supervised learning, common pitfalls include data leakage, not using a validation. Now let's move on to real-world applications of supervised learning. Supervised learning has various applications, including image recognition, speech recognition, sentiment analysis, and predictive analytics. These techniques are widely used across industries such as finance, healthcare, and marketing, with case studies illustrating their impact on business decisions. In summary, we've covered the introduction to supervised learning, the types of supervised learning tasks. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand the fundamentals of supervised learning. Distinguish between regression and classification tasks. Become familiar with popular algorithms. Learn how to split data effectively. Recognize the challenges of overfitting, underfitting, apply hyperparameter tuning, and model validation techniques. And appreciate the importance of evaluation metrics and avoiding common pitfalls. In the next class, we will explore advanced supervised learning techniques and their implementation in real-world projects. Welcome to the 16th Python programming class, Advanced Supervised Learning Techniques in Python. In this class, we will explore an array of advanced topics: ensemble learning, deep learning and supervised learning, transfer learning, model interpretability, handling imbalanced datasets using advanced libraries, real-world case studies, ethics in machine learning, hyperparameter tuning, and future directions. Let's begin with ensemble learning. Next, let's explore deep learning. Deep learning employs neural networks with many layers to model complex patterns. We'll implement deep learning for image and speech recognition using TensorFlow and PyTorch, highlighting best practices. Transfer learning enables the use of a pre-trained model on a new but related task. We'll explore case studies showcasing how this technique accelerates model training when labeled data is scarce. Model interpretability is crucial for Now let's address handling imbalanced datasets. Imbalanced datasets can lead to let's explore using advanced libraries. Advanced libraries such as XGBoost, LightGBM, and CatBoost offer optimized. Next, we will look at real-world case studies. Real-world applications showcase the effectiveness of advanced supervised learning techniques. Let's take a moment to discuss ethics in machine learning. Ethical considerations are crucial in machine learning. Now, let's consider hyperparameter tuning. Hyperparameter tuning significantly impacts model performance. We'll learn techniques. So finally, let's discuss future directions. The future of supervised learning looks promising, with trends in AutoML, enhanced model interpretability, and ethical AI gaining traction in both research and industry applications. In summary, we've covered ensemble learning, deep learning, transfer learning, model interpretability, handling imbalanced datasets, using advanced libraries. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand advanced supervised learning techniques. Embrace ensemble methods. Delve into deep learning applications. Leverage transfer learning. Ensure model interpretability. Consider ethics in AI and master hyperparameter tuning. In the next class, we will examine practical implementations of these advanced techniques with hands-on projects, including building and fine-tuning models. Welcome to the 17th Python programming class. Practical implementations of advanced supervised learning techniques in Python. In this class, we will focus on practical applications of the strategies covered previously, including implementing ensemble learning, building deep learning models, applying transfer learning, enhancing model interpretability, addressing imbalanced datasets, utilizing advanced libraries, and analyzing real-world case studies. Let's start with implementing ensemble learning. We'll code a random forest model for classification, using scikit-learn showcasing how to leverage multiple decision trees for improved accuracy. Next, let's focus on building deep learning models. We will implement a simple neural network using TensorFlow to classify images from the MNIST dataset, emphasizing best practices for model design. Now, let's delve into applying transfer learning. We will use a pre-trained model, such as VJGXT, to demonstrate how to fine-tune a model for a related task, specifically classifying new images with fewer training samples. Let's advance to enhancing model interpretability. We will integrate SHAP to visualize feature importance in a random forest model, illustrating methods to interpret model decisions and ensure transparency. Next, we will tackle addressing imbalanced datasets. We'll implement SMOTE to balance a dataset before training a classification model, demonstrating techniques to manage class imbalance effectively. Let's explore utilizing advanced libraries now. We'll implement a model using XGBoost to demonstrate its capabilities in handling structured data and achieving high performance for supervised learning tasks. We will review case studies showcasing successful implementations of advanced supervised learning techniques across various industries, assessing their results and methodologies. In summary, we've covered practical implementations of ensemble learning, deep learning. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Imbalanced datasets and implement advanced libraries for optimized model performance. In the next class, we will explore cutting-edge research in machine learning and its potential future applications in various domains. Finally, ensure all code snippets are tested and reviewed to understand their functionality deeply before applying them. Welcome to the 18th Python programming class, cutting-edge research in machine learning and future applications. In this class, we will delve into cutting-edge research topics in machine learning, exploring innovations, methodologies, and their potential applications in various domains, including healthcare, finance, and autonomous systems. Let's begin with recent advances in deep learning.
Never break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change.
Many breakthroughs have occurred in deep learning, including improvements in architectures like transformers and innovations in optimization techniques. We will review some of the most impactful advancements and their implications.
Saying what I mean and I bring it to the mad light. Ain't got time to kill, I got time to feel. I took a red pill, I know life's short so I wanna live real. But how's it supposed to feel?
Next, let's explore reinforcement learning innovations.
How's it supposed to feel? How's it supposed to feel?
Reinforcement learning continues to evolve with new algorithms that enhance learning efficiency and effectiveness in complex environments. We will discuss recent methodologies. Let's take a look at federated learning and privacy preservation.
Daily, pass me the jack, right as fuel, got me hazy. About to unpack all these things I've been chasing. I've got visions in my head, like memories after death. To be a legend instead of something you can forget. I'm living up every breath, I'd rather.
Federated learning offers a way to train models across decentralized data sources while preserving privacy. We will explore its architecture, benefits, and challenges. Let's discuss explainable AI. Say AI advances. The push for transparency in AI models has led to advancements in explainability techniques. We will review the latest research focused on making AI systems understandable for users and stakeholders, sir. Next, we will examine neural architecture search, NAS. Neural architecture search automates the design of neural networks. We'll explore recent progress in NAS techniques and their potential to design optimal architectures for various tasks. Now, let's focus on the integration of AI in cybersecurity. AI's role in enhancing cybersecurity measures has become pivotal. We will discuss innovative applications of machine learning to detect and prevent cyber threats effectively. Lastly, let's advance to advancements in natural language processing, NLP. Recent breakthroughs in NLP have transformed interactions with machines. We'll review the latest models and techniques that push the boundaries of what machines can understand in human language. Moving forward, let's discuss future trends in machine learning research. As we look toward the future, let's examine potential breakthroughs such as quantum machine learning, neuromorphic computing, and cross-disciplinary applications with fields like genomics and climate science. Before we conclude, it is vital to touch on ethical considerations in machine learning. The rapid advancements in ML bring essential ethical questions regarding bias, accountability, and societal impacts. We will review frameworks for ethical AI development. Lastly, we will present case studies of machine learning applications. We'll analyze real-world examples where machine learning has revolutionized sectors like agriculture, education, and transportation. This will allow for a deeper understanding of practical applications. In summary, we've explored cutting-edge research in machine learning, focusing on recent advances in deep learning, reinforcement learning innovation. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand recent research advancements in ML. Appreciate the role of deep learning innovations. Explore the importance of reinforcement learning and federated learning for privacy. Recognize the value of explainable AI. And stay informed about the integration of AI in cybersecurity and progress in NLP. Consider future trends and ethical considerations, and learn from real-world applications. In the next class, we will dive deeper into the interdisciplinary applications of machine learning in varying sectors, showcasing how these techniques impact different industries. Welcome to the 19th Python programming class, Interdisciplinary Applications of Machine Learning Across Various Industries. In this class, we will explore the interdisciplinary applications of machine learning in various sectors, including healthcare, finance, marketing, education, transportation, agriculture, and environmental science, highlighting how these techniques impact different industries positively. Additionally, we will touch upon the challenges and limitations faced by machine learning in these areas. Let's start with machine learning in healthcare. In this section, we will examine how machine learning algorithms are used for predictive analytics, diagnosis, treatment recommendations, and personalized medicine, showcasing successful implementations that have improved patient outcomes. We'll also discuss ethical considerations in healthcare AI applications. Next, we will explore financial applications of machine learning. We will analyze how machine learning is transforming the finance sector through fraud detection, algorithmic trading, and risk assessment, demonstrating the efficiency and accuracy improvements brought by these technologies, while also highlighting highlighting the regular challenges. Now let's discuss marketing and consumer insights. Machine learning models can analyze consumer behavior, optimize marketing campaigns, and personalize customer experiences. We will review methods leading to enhanced customer engagement and retention while considering the ethical implications of data usage. Next, we will delve in educational technologies. We will investigate how machine learning is used in adaptive learning systems, personalized education experiences, and performance prediction to enhance student learning outcomes, along with issues of accessibility and equity. Let's advance to transportation and autonomous vehicles. Machine learning plays a critical role in the development of autonomous vehicles and smart transportation systems. We'll examine how these technologies improve safety and efficiency in transportation while discussing public perception and regulatory challenges.
Misbehave just so you notice too. Sneaking looks up and down from across the room. Damn, what a hell of a view. I feel good, you look great. I like you, I can't wait. A first time, a first date. You're so fine.
Now let's focus on machine learning in agriculture.
You sip wine, I drink straight. Don't waste time to my place. I feel my heart erase. So catch me if I fall.
We'll explore how machine learning applications assist in precision farming, crop yield prediction, and pest detection, showcasing innovations that enhance agricultural productivity and sustainability, as well as discussing the impact on rural communities and economies.
I'm falling fast, sitting here praying that this night's gonna last. You got it all on tap, I'm loving your vibe, always have your back. We like all the same tracks, listen all night.
Lastly, let's review environmental science and conservation.
Falling fast, don't remember life before you, that's fact. I feel good, you look great. I like you, I can't wait. A first time, a first date. You're so fine, I'm so late.
Machine learning contributes significantly to environmental monitoring, wildlife conservation, and climate modeling. We will analyze the impact of these applications on sustainable practices and explore challenges in data collection and analysis. In summary, we've explored interdisciplinary applications of machine learning across various industries, including healthcare, finance, marketing, education, transportation, agriculture, and environment. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Recognize the interdisciplinary applications of machine learning in various sectors. Understand the specific use cases in healthcare, finance, marketing, education, transportation, agriculture and environmental conservation. agriculture, and environmental. Appreciate the impact of these technologies on industry advancements and efficiencies, and acknowledge the ethical and societal implications of their applications. In the next class, we will investigate the ethical implications of machine learning applications across disciplines and their societal effects, preparing us for responsible AI deployment. We will also discuss best practices for implementing these technologies ethically. Welcome to the 20th Python programming class, Ethical Implications of Machine Learning and Societal Effects. In this class, we will investigate the ethical implications of machine learning applications across various disciplines and their societal impacts, preparing us for responsible AI deployment. We will also discuss best practices for implementing these technologies ethically. Let's begin with understanding bias in machine learning. AI models can perpetuate and amplify biases present in training data. We will discuss the sources of bias, its implications, and methods to mitigate bias in machine learning models. Next, let's discuss transparency and explainability in AI systems. The complexity of machine learning models raises significant concerns around transparency. We will examine techniques and frameworks developed to enhance model explainability for users and stakeholders. Now let's focus on accountability in AI decision-making. Establishing accountability is crucial in machine learning applications to ensure ethical use. We will review frameworks for holding developers and organizations accountable for AI decisions. Let's address privacy and data security concerns. Data privacy issues are paramount. Especially when dealing with personal information, we will analyze laws and best practices that safeguard user data while utilizing machine learning. Now let's focus on societal impact and accessibility issues. The deployment of AI technology can widen existing socioeconomic gaps if not handled carefully. We will discuss the importance of ensuring equitable access and benefits to all societal groups. Next, let's examine regulatory frameworks for AI. With the rapid advancement of AI technology, regulatory frameworks are increasingly important. We will review current laws, proposed guidelines, and their implications for machine learning technologies. Let's present case studies of ethical challenges in ML. We'll analyze practical examples where ethical challenges have arisen in machine learning applications, illuminating the importance of ethical considerations in real-world scenarios. Before we conclude, let's discuss best practices for responsible AI implementation. Adopting best practices is crucial for the ethical deployment of AI technologies. We will outline methodologies and principles to follow, ensuring responsible machine learning development. In summary, we've explored the ethical implications of machine learning, focusing on understanding bias, transparency. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways: recognize the importance of addressing bias in L, understand the need for transparency and accountability, prioritize privacy and data protection, discuss the societal impacts of AI, explore regulatory frameworks, analyze ethical dilemmas through case studies, and adopt best practices for responsible AI implementation. In the next class, we will explore advanced machine learning techniques and their practical applications, including deep dives into specific algorithms and frameworks that enhance performance and efficiency. Welcome to the 21st Python programming class, Advanced Machine Learning Techniques and Practical Applications. In this class, we will delve into advanced machine learning techniques, discussing specific algorithms and frameworks that enhance performance and efficiency across various applications. We will also explore practical examples to cement our understanding. Let's begin with an introduction to deep learning and neural networks. In this section, we will explore the fundamental concepts of deep learning, architectures of neural networks, and their importance in handling complex real-world problems. Next, let's discuss convolutional neural networks for image processing. CNNs have revolutionized image processing tasks. We will analyze their mechanisms, including convolution layers and pooling layers, and how they improve image classification. Now, let's focus on recurrent neural networks for sequential data. RNNs excel in processing sequential data. We will discuss their architecture and applications, particularly in time series forecasting and natural language processing. Next, let's explore reinforcement learning and its applications. Reinforcement learning has unique properties that make it suitable for various applications. We will discuss algorithms such as Q-learning and policy gradients. Now let's focus on natural language processing with advanced techniques. We will review state-of-the-art techniques in NLP, including transformer models and embeddings, and their applications in text analysis and generation. Let's discuss model optimization and fine-tuning strategies. Optimizing machine learning models is critical for improving performance. We will explore techniques for hyperparameter tuning and reducing overfitting. Now let's focus on transfer learning. Best practices. Transfer learning allows leveraging pre-trained models for new tasks effectively and efficiently. We will discuss methods to implement transfer learning in various domains. Finally, let's explore real-world use cases and industry applications. We will analyze various use cases across industries that have successfully implemented advanced machine learning techniques, illustrating the impact on business outcomes. Let's discuss ethical considerations in machine learning. As emerging technologies in AI and machine learning challenge traditional ethical boundaries, it's crucial we understand these concepts. To conclude, let's look at future trends in machine learning and AI. We will explore future trends in AI, including advancements in unsupervised learning, federated learning, and their potential societal impacts. In summary, we've covered advanced machine learning techniques, including deep learning, convolutional, and recurrent networks. Before we conclude, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand the concepts of deep learning and advanced algorithms. Recognize the impact of CNNs, RNNs, reinforcement learning, and NLP, and apply model optimization and transfer learning in practical scenarios. In the next class, we will dive into evaluating model performance and metrics for machine learning, ensuring that we measure the effectiveness of our algorithms accurately. Welcome to the 20-second Python program class, evaluating model performance and metrics for machine learning. In this class, we will evaluate various performance metrics that are essential for assessing machine learning models. Understanding when to use each metric and how to interpret the results, we will also conduct practical exercises to apply these evaluation methods. Evaluating models is crucial for understanding their effectiveness in real-world scenarios. We will discuss different aspects of why evaluation matters in the machine learning lifecycle. Next, let's discuss classification metrics: precision, recall, and F1 score. For classification tasks, precision, recall, and F1 score provide critical insights into model performance, especially in imbalanced datasets. We'll define these metrics and explore their calculations. Now let's turn our attention to regression metrics: RMSE, May, and R-squared. In regression tasks, RMSE, May, and R-squared help assess how well the model predicts continuous outcomes. We will discuss their definitions and implications for model evaluation. Next, let's explore ROC and ALC for binary classification. The receiver operating characteristic, ROC curve, and area under the curve are crucial for evaluating binary classifiers. We'll review how to interpret these metrics to assess model performance effectively. Let's focus on cross-validation techniques. Cross-validation techniques help assess a model's reliability by testing it on different subsets of the data. We will discuss k-fold cross-validation and stratified sampling methods. Now let's examine model comparison and selection. In practice, choosing the right model involves comparisons across various performance metrics. We'll explore methods to compare and select the best performing model. Let's discuss the confusion matrix and its applications. The confusion matrix provides insights into the classification results, revealing true and false positives and negatives. We will analyze its structure and applications in model evaluation. Next, we'll have a practical session, evaluating a model using scikit-learn. In this hands-on session, we will implement a model evaluation using scikit-learn. Discretion, applying the metrics discussed and interpreting the results based on our model's performance. Let's reflect on common pitfalls in model evaluation. Understanding potential pitfalls in model evaluation will improve our ability to draw accurate conclusions from our results. We will discuss common mistakes and how to avoid them. In summary, we've covered the importance of model evaluation, including various performance metrics, their interpretations, practical applications, and common pitfalls to avoid. Before concluding, let's summarize the key takeaways from today's class and open the floor for questions. Key takeaways. Understand the vital role of model evaluation. Know the essential metrics for classification and regression tasks. Utilize cross-validation methods, and recognize common pitfalls in evaluation processes. In the next class, we will explore feature engineering and selection techniques to enhance model performance by improving input data quality and relevance. Welcome to the 23rd Python programming class, Feature Engineering and Selection Techniques for Machine Learning. In this class, we will focus on the crucial processes of feature engineering and selection, which can significantly enhance model performance by improving the quality and relevance of input data. Practical examples will be used to illustrate these concepts. Let's begin with an introduction to feature engineering. Feature engineering involves the process of using domain knowledge to extract useful features from raw data, aiming to improve model performance. This introductory section will emphasize its importance in machine learning. Next, let's explore techniques for feature creation. Transformations and interactions. Transformations and feature interactions can significantly impact model performance. We'll discuss techniques such as polynomial features and log transformations, as well as how to create meaningful interactions between features. Now, let's focus on handling categorical variables, encoding methods. Categorical variables need special handling in machine learning models. We will compare different encoding methods, including one-hot encoding, label encoding, and target encoding. Next, let's discuss feature scaling, standardization, and normalization. Feature scaling ensures that all features contribute equally to the model's performance. We will cover the differences between standardization and normalization, including their applications in various scenarios. Let's explore feature selection techniques. Filter, wrapper, and embedded methods. Feature selection is essential for reducing overfitting and computational costs. We will dive into various selection techniques and explain their pros and cons. Now, let's discuss reducing dimensionality, PCA, and TSN. Dimensionality reduction techniques can simplify datasets while preserving essential information. We will cover principal component analysis, PCA, and T-distributed stochastic neighbor, embedding, TCSN, discussing when and how to apply these methods. Next, let's discuss dealing with missing values and outliers. Handling missing values and outliers is crucial for maintaining data integrity. We will explore strategies for imputation and outlier detection, and their effects on model performance. It's time for a practical session. Feature engineering in practice. In this hands-on session, we will apply the feature engineering techniques discussed earlier on a real dataset, showcasing how they can impact model outcomes. Finally, let's cover evaluating feature importance. Understanding which features contribute significantly to model predictions is vital. We will discuss various techniques for evaluating feature importance and incorporating them into the model refinement process. In summary, we explored feature engineering techniques, methods for handling categorical variables, feature scaling, selection, dimensionality reduction, and dealing with missing values and outliers. Before concluding, let's recap the key takeaways from today's class. and open the floor for questions. Key takeaways. Understand the importance of feature engineering. Recognize various techniques for feature creation and selection. Apply scaling and dimensionality reduction methods, and handle missing values and outliers effectively. In the next class, we will cover model deployment strategies and best practices for putting machine learning models into production. Welcome to the 24th Python programming class, Model Deployment Strategies and Best Practices. In this class, we will focus on model deployment strategies that are essential for putting machine learning models into production. We will cover best practices to ensure smooth deployments and monitor performance over time. Let's begin with an introduction to model deployment. Model deployment is a critical phase in the machine learning lifecycle, where the trained models are integrated into a production environment. We'll explore the basics of what deployment entails and why it matters. Next, let's discuss deployment strategies. Batch versus real-time. We will compare batch and real-time deployment strategies, discussing their suitability for different use cases and the trade-offs involved. Now let's explore deployment tools and frameworks. There are various tools and frameworks available to facilitate model deployment. We will discuss popular options and how to select the right tool based on project requirements. Next, we'll focus on continuous integration and continuous deployments, CD. CI/CD practices are essential for modern software development. We will explore how to implement CI/CD for machine learning projects to automate testing and deployment. Let's discuss monitoring and performance evaluation. Monitoring model performance post-deployment is crucial to ensure ongoing accuracy. We will cover techniques for monitoring and evaluation, including the metrics to track a Now let's address managing model drift. Models can become less effective over time due to changes in underlying data patterns. We will discuss strategies for detecting and managing model drift. It's time to discuss scaling models for production. As the number of predictions increases, Scaling becomes important. We will review approaches for scaling machine learning models to handle increased load efficiently. Next, let's discuss security considerations in model deployment. Ensuring the security of deployed models and the data they handle is vital. We will look at common security risks and best practices to mitigate them. Now, let's move into a practical session, deploying a model with Flask. In this hands-on session, we will go through the steps of deploying a machine learning model using Flask, covering the entire process from coding to testing deployment. After the practical session, we will engage in a hands-on lab where you can experiment with different deployment scenarios, tools, and configurations. And key takeaways: understand the importance of deploying machine learning models effectively, recognize different deployment strategies, and implement best practices for monitoring, scaling, and securing deployed models. In the next class, we will delve into advanced topics such as ensemble learning and hyperparameter tuning to further enhance our machine learning models. Welcome to the 25th Python programming class, Advanced Topics in Machine Learning. In this class, we will delve into advanced topics such as ensemble learning, hyperparameter tuning, model interpretability, and the integration of neural networks with traditional models, which are crucial for improving and understanding machine-machine learning models. Let's begin with an introduction to advanced topics. The field of machine learning is vast, and understanding advanced topics can significantly enhance the effectiveness of your models. This section will cover the essentials of what we will discuss today, including the importance of integrating various techniques and methodologies. Next, let's explore ensemble learning techniques, bagging and boosting. Ensemble learning combines multiple models to improve performance. We will discuss bagging techniques like random forest and boosting methods such as add boost and gradient boosting, as well as their use cases. Now let's delve into hyperparameter tuning strategies. Hyperparameter tuning is essential for optimizing model performance. We will explore techniques like grid search, random search, and Bayesian optimization, emphasizing their advantages in different scenarios. let's discuss understanding model interpretability. Model interpretability helps us understand how models make predictions. We will cover techniques for interpreting model behavior, including SHAP values, LIME, and effective visualization methods. Next, we'll investigate neural networks and their integration with ensemble methods. Neural networks can be powerful when used alongside ensemble methods. We'll discuss the benefits and challenges of combining different learning paradigms, including practical examples of stacking and blending. It's time for a practical session, building an ensemble model. In this hands-on session, we will combine multiple models to create an ensemble, using the techniques discussed earlier, focusing on implementation and evaluation, including cross-validation techniques. Next, we will engage in a hands-on lab focused on hyperparameter tuning with grid search and random search. This lab will involve practicing hyperparameter tuning on different models using grid search and random search techniques to see their effects on performance, enabling comparison of tuning efficiency. In summary, we've covered advanced topics in machine learning, including ensemble learning approaches. Before concluding, let's recap the key takeaways from today's class and open the floor for questions. Key takeaways. Understand advanced techniques like ensemble learning, utilize proper hyperparameter tuning methods, grasp the concepts of model interpretability, and explore how neural networks can enhance ensemble methods in machine learning. In In the next class, we will explore unsupervised learning techniques, including clustering and association rule learning, to enhance our understanding of data patterns. Welcome to the 26th Python programming class, Unsupervised Learning Techniques and Applications. In this class, we will focus on unsupervised learning techniques such as clustering and association rule learning, which are pivotal for discovering patterns in datasets without labeled responses. Let's begin with an introduction to unsupervised learning. Unsupervised learning is a type of machine learning that uses input data without labeled responses. We'll discuss its significance and applications in various domains. We will focus on k-means and hierarchical clustering methods, discussing how they work, their advantages, and their use cases in analyzing groups within data. Now let's delve into dimensionality reduction techniques.